Hello everyone, Jan to all. In this video lecture, I am going to explain about introduction of theory of automata and formal language. First of all, I am going to define what is mean by theory of automata and formal language. Then we have to discuss about the basic concepts of automata. This is the outline. The first outline is introduction of Tafl. In this part, we have to discuss how the automata is defined and what is the need of this subject and what is the application area of this subject. Second point is application of Tafl, in which we have discussed the application of theory of automata and formal language. Second one is finite automata. Next, acceptance of string. In case of acceptance of string, we have a given machine and a given string. For the given string, we have to check the given string is accepted by the given automata or not. We will discuss in acceptance of string. Then we have discussed about types of finite automata. In case of types, we have discussed there are two types of finite automata. The first one is deterministic finite automata and second one is non-deterministic finite automata, which is discussed later on. This is the introduction part, in which we discuss about the definition of theory of automata and formal language. In theory of automata and formal language, there are four words: theory, automata and formal language. Theory of automata discuss the abstract model of digital computer, in which there are a digital computer, a machine like a digital computer, which process the given string accordingly. Next one is formal language. In case of formal language, we have to define the language. Language means, simple language means a language can be defined as a mean of communication. But here we discuss about the formal language. Formal language means a language which is used to process the string, or a language which is processed by a given machine is called formal language. In this language, we discuss different types of language which is processed by the different types of machine. The first simple machine is finite state machine, which is the basic parts or basic machine of a finite automata, in which we have discussed two types of machine: deterministic finite state machine and non-deterministic finite state machine. But the non-deterministic finite state machine is typical in implementation, so that we have to convert and non-deterministic finite automata into deterministic finite automata, and then we have to implement the given machine in a digital computer. In case of theory of automata and formal language, also known as theory of computation, this is the main subject which is known as theory of computation. How the language is processed, how the string is processed, and how the machine is executed the given language or processed the given language is known as theory of computation. Is a theoretical branch of computer science. This is a theoretical or logical branch of computer science, in which we have discussed some logics, some string which is processed by a given machine. Theory of automata and formal language mainly deals with the logic of computation with respect to simple machine, refers to as a automata. Automata means a simplified machine, that is also called an abstract model of digital computer, in which we have to process the given string by sequentially. This is the simple machine, as well as it is refers as automata. Next one is Tafl is the abstract model of digital computer or machine, or abstract model of a digital computer. Theory of automata is mainly discussed on this part, the abstract machine. Abstract machine means we have only focused on input as well as output. How the internally work, this is the latter part, and we discuss the how the machine is execute process the given string sequentially. The next one is theory of automata and formal language is a mathematical model of digital computer. This is a mathematical means how the string or how the mathematical expression is executed inside a digital computer is discussed in a theory of automata and formal language. The next one is automata originated from the word automaton, which is the closely related to automation. This is the part of automation, how the system is modified or how will the system is process the given string. We will discuss in automata. This is the all about the definition of theory of automata and formal language. Now the next topic is application of theory of automata and formal language. In case of application, the first application is theory of automata and formal language are used in an artificial language. This is the main application area of automata. Automata is mainly used in artificial intelligence, embedded system which is designed for executing the complex program or complex system which is interconnected to each other. But the most widely used application is in compiler construction. This is the subject which comes in third year, but here we have discussed application so that we talk about the compiler construction. How the compiler is constructed or how the compiler is designed, it is also used in the compiler design or compiler construction. They check whether a language written is correct or not. This is also check a given sentence or a given string is in a correct format or not, or the syntax of the string is correct or not. This is the main application of theory of automata and formal language. The next application is automata enables scientists to understand how machine compute the function as well as solve problem. This is the application which is used for a dynamic programming in which we check or solve the given problem by using the particular machine. The third application is the main motivation behind developing automata theory was to develop method to describe and analyze the dynamic behavior of discrete system. For a different output system or a discrete system, we have to design a dynamic behavior machine which execute the given language in a particular manner. This is the advantage of a theory of automata and formal language. Now, this is a diagram which show the automata are finite automata, that is called FA in short form, or finite state machine. This is the FSM which is show the different part. The first part is input file, second part is control unit, third part is storage, and fourth one is output. This is the total 5 components. Main one is first one is input file, control unit, storage, and output. In control unit there are 2 parts. There are internal states and transition function. Mainly here in a block there are 4 components, but in control unit we have to discuss different types of function which is executed inside the control unit. This diagram is similar as a digital computer. In digital computer also we have a input, there are a control unit, there are a storage, and then we have to generate output. Here we discuss about what is mean by input file. Input file is divided into a equal size of block that is called cell, and each cell is store a single symbol. That means if there are a number of symbols, then we have to store a single symbol on each cell. This is the functionality of input file. That means input file is divided into equal size of block called cell, and each cell contain a single symbol like this. There are A, B, C, D, and so on. Here this is the control unit. Control unit contain transition function, internal states, internal state having also initial state, set of final state, etc. This control unit control the overall movement of the transition function, where the present state, how we have to move on next state. This is decided by a control unit. Control unit is the main part of the digital computer in which we have to take decision how we have to move one state to another state, and how we have to take input, which output is generated and how we have to move from one state to another state. Now the next part is storage. Storage is the a temporary buffer which is used to store the value, and after storing or calculating the value or processing the value, we have empty the storage and we generate desired output. Output function is return the value according to the given input, which is our result. This is the all about the finite state machine. Here we also define what is mean by automata. An automata is a abstract model of digital computer, which is discussed previously. This is the abstract model. We only know how the output is generated, how the state to be modified, how the control to be moved from one state to another state. This is the functionality of automata. Now, in the previous figure, these are the mainly four component: input, control unit having internal state, and internal state having initial state, next state, and final state. After that, transition function is also the part of control unit, then storage, after that output. As we discussed, input means input file is divided into equal size of block, that is called cell, and each cell contain a single symbol. Then control unit having internal states and internal state having initial state. Initial state are those states from where we have to start processing or start accessing the machine. Next state, after taking the input and processing the input string, we have to move on a next state, then final state. This is the state where we have to stop or halt after processing the given string accordingly. Transition function tells us how we have to move from one state to another state by taking input. This is decided by a transition function, and transition function is a form of triplet. We discuss later. Now storage, this is a temporary storage memory where we have to store the given data or process the given data, and last one is output, which is give the desired output according to the given input. This is the finite types of finite automata. Before coming on this topic, we want to discuss about transition function. The format of transition function is like this: delta qi comma a equal to qj. This is the initial state. That means we have to start with this state. This is the input. At state qi, we have to give an input a, and we have to move on next state qj. This is our next state. So this is the format of transition function. We have represent transition function in the form of delta. Now, finite types of finite automata. The automata is divided into two parts. The first one is deterministic finite automata, and second one is non-deterministic finite automata. In this topic, there is a main question is, what is the difference between deterministic finite automata and non-deterministic finite automata? In case of deterministic finite automata, for a present state and a given input, one and only one next state. But in case of non-deterministic finite automata, for a given input and a present state, there may be more than one next state is possible. This is the main difference between deterministic and non-deterministic. For example, if we have to write delta state q input a, then the next state is q dash. This is the fixed. This is the for deterministic. If we write delta state q input a and the next state is q dash comma q double dash, there are two next states, then this is the case of NDFA. This is the main difference between deterministic and non-deterministic finite automata. In deterministic finite automata, a deterministic finite automata is one in which each move is uniquely determined by the current configuration. That means there is a single movement for a given input as well as present state. If there are more than one next state, then that is the case of non-deterministic automata. But in case of deterministic automata, there are one and only one move is possible. Here, a definition of deterministic finite automata. A deterministic finite automata, DFA, defined by 5 tuple. This is a tuple definition in which Q, sigma, delta, Q naught and F. This is the 5 tuple in which Q is the set of all state. All state matlab means Q is a finite set of all internal state, in which initial state also, in which final state also, or in which next state also. That means the set of all states is called capital Q. Now the next point is sigma. Sigma is the set of input symbols in which symbol which machine takes as a input is called sigma. Sigma contain small letters which is in the letter class we have discussed as a terminals, but here we have to discuss sigma as a input symbol. Then delta. Delta is the transition function and it is defined as Q cross sigma implies Q. That means you look at this point here, delta is written as delta Q naught A equal to Q. So the mapping is Q cross sigma because in left hand side state and input, so that we have to write here Q cross sigma, and in right hand side only state, so we have to write implies Q. Now Q belongs to capital Q, that means Q naught belongs to capital Q. This is a initial state, means we have to start our machine from Q naught. This tells us how the machine, from which point we have to start the machine is decided by Q dot. In given machine, only one state is initial, which may be Q naught, which may be Q1, which may be Q2, which may be Q3. But final state may be more than one, so that we have to write here F is the subset of capital Q and is the set of final state. In a given machine, initial state must be a single, but final state may be more than one, so that we have to write here F is a subset of capital Q. This is the transition function which is defined. This is the next state which is so here. This is the initial state, that is also called, this is the input symbol, and this is the initial state, that means present state, which is the discussed in previous slides. This is the format of transition function which decides the present state and input, which state to be next state according to the given state or given transition function. This is the definition of deterministic finite automata. Now, some properties of transition function. This property is used when we have to we want to process a given string for a given machine. The first property is delta Q input null. This symbol is known as null. Delta input null equal to Q. That means if we have to give a input as a null, then there is no change of state. We have to persist on that state. Now the second property is delta Q AW. How this string is processed? First we have to take delta Q input A. We process this string. After coming the next state, let Q dash, then we have to take here Q dash and now process again delta Q dash input W. By using this method, we have to process one by one input symbol and goes on last. When we get the input as a null, we announce the string to be finished and check the state is final or not. If the state is final, then string to be accepted, otherwise rejected. This property is similar like the previous property. Here we have to write Q, W, A. First we have to process W, then A one by one, because we at a time we have to process single symbol at a time, like this: Q, input A, then move on Q dash. After taking Q dash next state, we take input next state and process accordingly. This is the three properties which is used in the next example, in which we have to show how the string is processed or how the string is accessed through a given DFA. Now, this is the representation of DFA. How the DFA is represented inside the computer memory, and as well as how the NDFA is also represented inside the memory. This is the method which is used to represent a DFA or NDFA inside the memory. The first method is by transition function, which is discussed, or this is the example which is show the machine by a transition function. This is a transition function which is used to represent the machine inside the memory. Next one is by transition table. This is the second method which is used to represent the machine, and all the representation is mutually convertible. That means transition function is converted into table, table is converted into transition function. The last one is by transition graph. It may be transition graph is converted in transition table, as well as transition graph is converted into transition function. All the transition function or transition function table is also converted into transition graph. Now, the first method of representation is transition function. This is a machine which is shown by a transition function. Here, delta Q0 input A, the next state is Q0. Delta Q2 input 1, the next state is Q1. Delta Q1 input A, the next state is Q1. The next is delta state Q0 input 0, the next state is Q2. Delta Q2 input 0, the next state is Q2. And delta Q1 input 0, the next state is Q1. This transition function may be converted into transition table as well as transition graph. How we have to convert this transition function into transition table? Like this: we have to take here present state, here next state for 0 and 1. Present state means we have to write here all state in first column, Q0, Q1 and Q2. Now, state Q0 input 0, state Q0 here, state Q0 input 0, the next state is Q2. State Q0 input 1, state Q0 input 1, the next state is Q0. We have to write here Q0. State Q1 input 0, state Q1 here, state Q1 input 0, the next state is Q1. State Q1 input 1, state Q1 input 1, the next state is same Q1. State Q2 input 0, the next state is state Q2 input 0, the next state is Q2, and input 1, the next state is Q1. This is the transition table. We have to convert transition function as a transition table or transition table as a transition graph. The next one is, if we want to represent this transition function in a graph, we represent like this: state Q0 input 1, the next state is Q0. State Q0 we mark as a circle, input 1, the next state is Q0. State Q0 input 0, the next state is Q2. We draw a directed edge Q0 to Q2, input 0, the next state is Q2. State Q2 input 1, the next state is Q1. State Q2 input 1, the next state is Q1. State Q2 input 0, the next state is Q2. This is the self loop of 0. State Q1 input 1, the next state is Q1, mark a self loop of 1. State Q1 input 0, state is Q1. We also mark a self loop of 0. This is a diagram of the given transition function. So, we have to convert any transition function into transition table into transition function, transition graph into transition table, or transition table into transition graph. One more notation is also used. One more notation is, in table, we have to mark entering arrow for initial state and circle for final state. In same mark used for diagram, entering arrow for initial state and a double circle for final state. This is the identification of initial and final state in the given diagram or table. When the question is given in the form of transition function, they also specify what is the initial state or what is the final state, they mention accordingly. This is a transition graph, which is discussed in previous slides, how the graph is converted, how the transition table is converted into graph and the graph is converted into transition table. If we want to write the transition function of this graph, we write easily. How? Q naught input 0, state is Q naught. We have to write delta state Q naught input 1, the next state is Q naught. We have to write state Q naught input 0, next state is Q2. We have to write delta state Q naught input 0, the next state is Q2, and so on. State Q2 input 0, the next state is Q2. We have to write delta Q2 input 0, the next state is Q2. State Q2 input 1, the next state is Q1, and state Q1 input 0, the next state is Q1. State Q1 input 1, the next state is also Q1. This is the transition function for the given diagram. We also represent this diagram by table. We take same, we construct a table in which the first column is for present state, next for 0 and 1. We have to write here initial state Q naught, Q1, Q2, and we check for input 0 and 1, and we have to enter in the given table. This is the transition graph representation of a automata. This is a transition table which is discussed in previous slides. We can also convert this table into transition graph or transition function easily. We have to write like this. If we want to write transition function of the given table, how we have to write? This is the present state, this is the next state for input 0. We have to write delta state Q naught input 0, the next state is Q naught. State Q naught input 1, the next state is Q2. We have to write delta state Q naught input 1, the next state is Q2, and so on. We have to write like all the transition function according to given state. We have to check for all state. We have checked Q1 for input 0 and 1, Q2 for 0 and 1, and we also draw the diagram for the given transition table. This is a question on finite automata. This question is check for a given string is accepted by the given automata or not. When a string is accepted, the state must be a final state. For example, this is a finite state machine, and the given string is 0, 0, 1, 1. We want to check this string is accepted by this given machine or not. How we have to check? First, we have to write delta initial state is Q naught, and we have to write here all string 0, 0, 1, 1. State Q naught input 0. What is the next state? Delta state Q naught input 0, state Q naught input 0, Q2, and we have to left this string. Now we have to write remaining string 0, 1, 1. Now state Q2 input 0, state Q2 input 0, the next state is Q naught. We have to write here Q naught 1, 1. Those symbol we have to take input, we have to left out those symbol, and we have to write remaining symbol. Now state Q naught input 1, state Q naught input 1, the next state is Q1. We have to write here Q1 comma 1. Now Q1 input 1, Q1 input 1, the next state is 0, Q0. You have to write here Q0. After exhaust of all string, we have to write here null. Now delta state Q naught input null, we have to write here Q naught. There is no change of state. The state here we have to copy same state in the next part. Now we have to check this state belongs to final state. If S, the string to be accepted, otherwise rejected. But here Q naught is a final state because Q is a circle and Q naught is a final state, and after processing all string the state to be a final state, hence this string is accepted by the given automata. This is a question on processing of string or acceptance of string by a given automata. And here we have to mention definition. A string accepted by a finite automata M equal to this if delta Q naught A equal to Q for some Q belongs to F. Agar if Q belongs to final state, then string is accepted, otherwise rejected. A final state is also called accepting state. This is mentioned here also. Final state is also called accepting state. This is the definition of non-deterministic finite automata. We discuss here because in a previous slides we discussed the deterministic finite automata. A deterministic finite automata, those in which each move is uniquely determined. That means there are one and only next state, then the machine is called a deterministic finite automata. Next definition is a non-deterministic finite automata defined by same of 5 tuple Q, sigma, delta, Q naught and F. The meaning of these symbols are same. Q is the set of all states, sigma is the set of input symbol, delta is the transition function, but mapping is little bit different. In case of deterministic, this is only Q, but here 2 power Q. This is the main difference between deterministic and non-deterministic finite automata, because in case of non-deterministic finite automata, more than one move is possible, so that we have to write here 2 power Q. This is the case of deterministic finite automata. Now Q naught belongs to capital Q. This is the initial state and F is a subset of final state. This is the discussed in previous slide also. This is the all about NDFA, and the next topic is how to convert NDFA into DFA, how to minimize DFA. This is the next topic which is discussed in next video. This is all about the basic of theory of automata and formal language, mainly finite automata, deterministic finite automata and non-deterministic finite automata. The next we will discuss in next video. Thank you.